All right, so I'm going to chat about exposing the number of interactions to web developers. So let's go over the goal first. What we'd like to do is to enable computing input latency metrics on pages. And this is useful for analytics providers where they don't have full knowledge of what the site is doing, so they need to rely on heuristics that work for most pages. This is also useful to create metrics that can compare the performance across multiple sites. And as I've talked several times in the working group before, we established that the way to do this requires grouping certain events together as a single user interaction, since they are caused by one single user interaction. So we exposed interaction ID for in-event timing to group events that correspond to the same interaction. So what is an interaction? It can be a key press, and what are events associated with key press? They can be key down, key up, or input event. As a note here, we use mostly key down and key up, but for IME and certain types of virtual keyboards, we have basically we have composition events, and so we use the input events in those cases because the key events are not actually representative of what's actually being sent to the page. And this happens on a lot of Android keyboards, and it happens on Japanese typing, Chinese, and several languages. And other type of interaction is tap or drag. So for those, we care about the pointer down, pointer up, and the click. So it's basically, for the tap, it's just when you tap down and then tap up. For the drag, it is covering the initial part of the drag and the release part of the drag. So not really the full dragging motion. Now, we expose interaction ID and event timing to enable developers to easily know which events correspond to which interactions, because sometimes they may happen far apart from each other, and it's quite complicated to create a state machine to actually compute which events correspond to which user interactions. So we actually just did it in the browser, which has a little bit more control over everything that's going on. So it's a little bit easier to do that in the browser. Now, we want to enable knowing those interactions, but we also expose other kinds of events. So the interaction ID is 0 when the entry does not correspond to a user interaction from the ones that I just defined. So one problem that we've reached now is that even though developers can know which entries correspond to the same user interaction, it's hard for them to know how many of those such interactions have occurred on a given page load. Now, obviously, there's a bunch of metrics that require knowing the number of user interactions. And I just listed 2 of the more obvious ones, which is like average. For example, if you wanted to compute average input delay or average duration of user interactions, then you would require knowing how many of them there are. And similarly for median or some other percentile, it's also just much easier to know how many of them there are. So the reason we don't know as of today how many there are is because the observer exposes entries after a certain duration, so not all entries. And so it's possible that an interaction is super fast, meaning all of the events that compose it do not make the cut. And so the developer will never receive any entry for such interaction. So it would be hard for them to know that it took place in the first place. So having that problem in mind, I'm going to talk about several, basically brainstorming solutions about what are ways we could actually expose this information. And then my hope is for people in the call to look at all the solutions and be like, I like this one and this is why. So that's kind of the idea of the presentation. So just keep that in mind while I present them. So first solution is extending event counts. So the idea would be you can either add a new key in the map for interaction, or you can add 2 or 3 keys, one for each interaction type. So the first example is just performance.eventCounts.get interaction. Notice that event counts is a map-like interface. So it's like a map that you can already call in JavaScript. It's in the spec and it's shipped in Chrome already. So the difference here is that event counts is usually for event types. So things like give me the number of clicks. So this is click events. It's a little bit different semantically from what we mean by user interaction. So that's kind of the downside of this proposal, is that it's cramming different, semantically different things into the same map, if that makes sense. So to try to counter that problem, the second solution is basically do the same, but in a different map-like interface, which will have a separate name, like interaction counts. So it's just like creating a new map where you can have the interaction counts. So you can have, for example, give me how many keyboard interactions there have been on my page. And this kind of goes around the problem of having those event types and interaction types grouped together in the same map, which is potentially confusing. So that's the second solution. Another solution is if we think that developers would not really care about the different types of interactions, meaning keyboard or tap or drag, then we could just have a single integer in the performance interface, which is just give me the number of interaction counts in the page that we have seen so far. So the benefit of this one is we don't have the horrible map structure that event counts requires. I suppose that's more of a downside for us developers because it's horrible to implement, but for web developers, it's almost the same, right? So here it's just a little bit simpler. It's just a single number, how many interactions have occurred in the page. And the next one is allow duration threshold to be zeroed. I have talked about this one a few times where I've run into problems because of the fact we have a duration threshold that is minimum 16 milliseconds. What that means in practice is that entries that have a duration below that minimum duration threshold can never be surfaced to the performance observer, right? And this is kind of what got us into this problem. So one option is to say, well, let's just let a developer say, I want all the entries. Now, the problem with this is that event timing actually exposes many kinds of events. So by doing this, getting rid of the threshold, it could potentially become a little bit expensive because remember that every time an entry is created, you can potentially post a task that the user agent has to run to let the developer run the callback. So there could potentially be many cases where the developer is running a callback where they don't care about any of the entries that are in that callback simply because they're not of the type they wanted. So we could do this, but I would potentially like, if we went with this one, to introduce other ways of filtering out the entries directly from the observer. You can filter them in the callback, of course, but then you've already incurred the cost of calling the callback, if that makes sense. So that is the fourth brainstorm solution. And lastly, another option is to expose entries with interaction ID. So as I mentioned before, these are only some kinds of entries for the specific events that we've defined as interactions. Those have their interaction ID set to something that's non-zero. So we could just say, well, those entries are exempt from the duration threshold limits, and they are just surfaced by default. Now, this has a little bit of a problem that it kind of breaks the assumption that the duration threshold is a duration threshold, because then the developer will be like, oh, this is like a super fast event. Why am I getting the entry for this event? So that could introduce that kind of confusion. So that's the end of my rambling. Thanks, everyone. And now to the part that I mentioned before, the discussion. Let's vote on our fave solution. And yeah, thanks.